To kick off the first part of our main series, The Celestials, let's first figure out what is a planet. Although, if you have no idea what a planet is, get off this channel. I'm just joking. I mean, that's why you're here. And also, I need the views. A planet is
an astronomical body orbiting a star or stellar remnant that is massive enough to be rounded by its own gravity, is not massive enough to cause thermonuclear fusion, and has cleared its neighboring region of planetesimals.
Yeah, I knew that, obviously. But what does all of these really big words really mean?
So what this means is that a planet is a celestial body. If you don't know what that is, watch my previous video, please, I'm begging you, I need the views and subs, that orbits a star or stellar remnant, which is the corpse of a star, like a black hole, that is big enough to be spherical by its own gravity, but not too big that it becomes a star.
Simple, simple.
I know that I've used this word starting twice in a row, please don't judge. So there are obviously many planets in the universe, but how do we classify them?
Simple. The ones with rings, the ones with no rings, by color, by size, by shape, by how beautiful they look. Yeah, right? No. Well, sorry Jimmy, or in this case, for your Daryl, that is not how you classify planets because...
Facts don't care about your feelings. Astronomers classify planets into the following groups: the terrestrial planets, the gas giants, and the ice giants. Terrestrial planets are planets that are made of rock, like the Earth. Basically, these planets are solid.
Yes, that means there are planets that aren't entirely solid.
With the exception of Mercury, all the terrestrial planets have atmospheres. Gas giants are massive planets, many times the size of Earth, that are made of gases like hydrogen and helium, meaning that they do not have any solid ground except for their cores, which is rocky and made of metal.
Something I found out by watching a documentary years ago as a kid, yes, my life is actually that sad, is that below the atmospheres of the gas giants, there's liquid.
Liquid metallic hydrogen, due to the extreme pressure down there. Ice giants are like small gas giants that are made of water, ammonia, and methane, materials that has low boiling points and are heavier. Although they do have hydrogen in their atmospheres, but a lot less compared to gas giants. And what's cool about ice giants is that they might have a supercritical, where distinct liquid and gas states no longer exist due to pressure, water ocean, comprising 2/3 of their mass.
Now the formation of these ice giants are really interesting, but I'll cover them in future videos. Firstly because of simplicity, but also because I'm a really lazy person. For as long as humans had eyes, we have seen the planets with our eyes.
With the naked eye, you can see Venus, Mars, Jupiter, and Saturn. And what sets them apart from the stars is that they move across the night sky, that is. The ancient Greeks called these wandering stars, I'm not sure how to pronounce this, wanderers, which is why they are now called planets. One thing that all these ancient cultures had thought was that the Earth was stationary and the center of the universe, and that the planets moved around it. The ancient cultures also named the planets, and the names we know today are from the Romans, who named them after their gods. Although modern Greeks still call the planets by their ancient Greek names, but other languages, especially those influenced by the Catholic Church and the Romans, still call them by their Roman names, like English. Meanwhile, for Chinese and other countries of Chinese influence, like Korea and Japan, Vietnam, use a naming system based on the Chinese elements of water, metal, fire, wood, and earth, which explains a lot now. Because when I was learning about the Chinese name of the planets, yes, I'm actually that sad that I actually bothered to find it out, I always wondered why they are called that way. Like Mercury is called Shui Xin, which literally means water planet. Like what, Mercury has no water whatsoever, it doesn't even have an atmosphere.
But hey, now I know from researching this video, and so do you too. Learn it.
Although by the 18th century, thanks to scientific pioneers Galileo, Kepler, and Copernicus, and better telescopes that is, it became accepted that the Earth isn't the center of the universe, and that all the planets, including Earth, orbited the Sun, and not the other way around. However, if you snoop around the internet long enough, you will find your fair share of deniers, conspiracy theories, and everything in between. Anyways, back to the 18th century. In 1781, Uranus was discovered using a telescope. I know there's many ways to pronounce it, but I'm just gonna call it Uranus.
I swear if I see one your anus joke in the comment sections, you're gonna be banned and blocked.
Later, in the 19th century, Ceres was discovered, and soon afterwards, many other such planets within the same region, but soon they were reclassified into star-like objects called asteroids due to their small mass. In 1846, Neptune was discovered, this time through math, but I won't go into the details today because I will cover this in the Neptune video which will come up probably next year or something. In 1930, Pluto was discovered and became the 9th planet until 2006. I'll go into the details later. In 1992, we found the first exoplanet, a planet outside our solar system orbiting a pulsar in this case. So surprise, surprise, there are planets outside our solar system orbiting other stars. I mean, come on. Do you really think that our sun was the only star in the entire universe to have planets? I mean, it does make some sense that other stars will have planets, and with sci-fi being so popular, it wasn't really a shocker that we found it. So here's where things get really complicated, probably because it's in the 21st century. During the 1990s to early 2000s, astronomers kept finding more and more planets around Pluto's orbit. This eventually led the IAU to meet up in 2006 and address the issue, and that is why Pluto is no longer a planet, and it's a dwarf planet, as the planet must now clear its surroundings of other planets, or dwarf planets, something Pluto didn't do.
I was actually alive when this change occurred and starting to learn about space, but I was only 4 years old, so I vaguely remember anything. Most I remember of it is from years later watching documentaries. Well, some of the books from that time period, sounds like I'm old, from that time period has still stated that Pluto is a planet. Of course, I don't have any evidence of it because I threw away all my books years ago. Oops.
So like all things in the universe, planets are, well, born-ish. The main theory is that planets and their stars are formed from nebula collapsing. A protostar is formed in the center and is surrounded by a protoplanetary disk. The actual planets are formed through a process called accretion, where particles accumulate to form larger objects. The objects turn into planetesimals, which turn into protoplanets, which eventually collide to form planets. Yes, it's very violent. When a planet becomes Mars-sized, it forms an atmosphere and depending on its location, gets more gases until it becomes a gas giant. All planets form the same, but what they become depends on their conditions. Inside the planets, the interior starts to differentiate, with the lighter material at the surface and the denser ones at the core. When the protostar becomes a proper star, it blows away the remaining disk through ways I don't want to go into. All that remains is a lot of protoplanets which collide until they form proper planets. Those protoplanets that survive may get captured and become moons or will remain as asteroids and comets. You see, it's all connected. Isn't it poetic? Yeah, you don't care. So planets, even ones that are vastly different from each other, have similar characteristics. I will briefly cover this as future videos will go deeper into each attribute as I cover each planet. But here are the similarities. Dynamic characteristics that are similar within planets include all planets must orbit a star, but their orbital characteristics can be quite different, with some planets having long elliptical orbits like Pluto. There's more to the orbits, but I'll cover them in later videos. Next, all planets have an axial tilt, where they tilt along the axis, giving planets seasons. All planets rotate, which is the definition of a day, but their lengths aren't the same. As I've said earlier, planets must clear their orbits, which is why Pluto isn't a planet anymore. Now on to the physical characteristics. Each planet must be massive enough to force itself into a sphere. All planets have varied interiors due to how they form, as in they have layers, which I said earlier. Most planets except for Mercury has atmospheres, as I've earlier said. And with the exception of Venus and Mars, all planets have a magnetic field. Oh, and all the gas giants actually have rings, not just Saturn, whatever. Shocking, I know.
And there you have it, the definition and explanations of planets in a hopefully digestible video. That will be all.
I watched the entire video and I mentally pooped it out. Digestible.